Hey everyone, for this video, I've planned something new. You see, till this point, I've always stayed in my comfort zone doing Python. However, I recently started my studies, and within those studies, I had to program in MATLAB. So, MATLAB, if you don't know, is like a specific tool to handle and deal with matrix. It is short for Matrix Laboratory. So I guess if you clicked on this video is because you want to learn about MATLAB in a very short video. I will not ask you for legal purposes where you got your MATLAB software. Personally, I got it from the license of my university, so be assured. So we are legal right here. But I don't mind if you're more adventurous and want to go on the pirate path, you know? Anyway, so when you see this window right here, you see it is made up of several widgets here, here, and here, and here. It can be a little bit overwhelming when you start out. The most essential thing you need to know. First of all, this plot you will not need. Apps, it is less likely you will not need, especially when you're trying to begin learning MATLAB. Focus on this home tab, okay? And within this home tab, again, there will be a lot of things, but let's try to break it down step by step. Now, this part right here is everything that deals with files. So for example, if you want to create a file, if you want to create a function, you will see this a bit later on. If you want to open a folder, if you want to, for example, look for a file and so on and so forth, it'll be this part right here. You can see there is new script, and then you can also open a folder. Now you will not really need any of these for now. Maybe the layout, but not specifically. Let's say you don't have the same view as I do. What you gotta do here, you go on layout, and then you will see this show. I can see the current folder, so this one is the current folder. Basically, it, in a way, displays all the files on the current working directory you have. For example, right now I'm on my documents under MATLAB, okay? So if I go ahead and open this file right here, okay, so it's on documents. Let's say here I create a new file called, or a new folder called new folder. Intuitive name, I know, okay? You can see that it got created right here. If I create a new file, for example, a text file, my text file, okay, you see it got created right here. So in a way, it is your current working directory. This is your current working directory. You can go ahead and delete all of these, okay? Now, before jumping to the command window, I want to speak about the workspace and the command history. Now, the workspace is the widget, in a way, that will contain all your variables and some information about your variables. And then this command history will contain all the commands that you wrote in this command window. Now, what is this command window? This command window simply is a window where you write commands. For example, I can go ahead and say a is equal to 0. This is a command. I can say this a. This is also a command. I can type in, for example, x is equal to linspace from 0 to 1 plus 10 points. This is also a command. So you will see here that all of our commands have a history. And then this history, if I double click on this one, it will automatically paste that command into our command window and run it for ourselves. You can see here, if I double click here, it just gets executed. And you will notice that now in our workspace, we have two new columns. So 2 columns and 2 rows. So this is the first row and this is the second row. In the first row, we have the variable name a, and its corresponding value, which is 0, and same goes for x. Now, for example, if you have a more complicated file that contains 10, 50 variables, you can have a quick summary look at all your variables within this window right here, so this workspace. For some reason, you don't see any of these windows, you gotta go on layout here, and then on your show, you can either show the current folder, I can hide the current folder or redisplay it, or the workspace, the command history, and then the quick access toolbar. So basically all the widgets you want to view on your window. Let's say you create some bunch of commands, you know how to make commands within MATLAB. Now you want to create, now what you want to do is to clear your workspace as if you're working on another file, for example. Now, it is cluttered up here. For example, let me just clutter it up a little bit more. So let me say b is equal to 0, c is equal to 0, d is equal to 1, e is equal to 22 to the power of 3, for example, a plus b plus c minus d. It is very messed up. Let's say you downloaded MATLAB, you installed MATLAB, you wrote a little bit of commands to get you started with MATLAB, but you want to actually clear the command window since you want to move on and try something else. Maybe you want to try now writing if statements or loop statements. or you want to define a matrix, for example. Now, you can go ahead and do this, like to, in a way, clear your workspace, but this does not really achieve it in a very efficient way. What you can do, however, is you do a CLC. Now, CLC is short for clear command. If I do this, you can see that all our commands got cleared. Now, they still remain in our history in case you want to take them back, but in our current command window, it is clear, so we can start working again. But if you notice here, we still have our previously defined variables. So we cleared a command window using the CLC. CLC, this clears the command window. Now, to clear the workspace, you do a clear. If you do clear, you see we just cleared our workspace. Now, a good habit to have is whenever you start writing code, you do a clear colon, you do a clear semicolon, and then a CLC semicolon. This is a good practice to have whenever you want to start working on your script. Now, this is good and all to write down your script or commands directly in the command window. But let's say now you want to learn how to write a file that contains multiple commands. Maybe it contains a if statement, a loop statement, where you will be calling a function that do some operations on a matrix and so on. This will be a bit tricky when doing on the command window. So let me do again a CLC and then a clear. To achieve this, you are simply going to use a script. A script is, for example, a file that contains multiple commands. Here, if you go under New Script, you'll see that it will generate another window or another widget called an editor. Now, it is within this editor that you will write all of your scripts and line of codes. Okay, so let me actually reduce this now. Notice here that we have another tab called editor. Okay, I can go ahead and start doing a CLC and then a clear. This is a very good practice whenever you want to start writing your MATLAB code. Okay, and let's actually say that a is equal to 0, and then I want to disp a. So disp, in a way, is equivalent to just outputting the current variable of a. For example, if I do disp a, and then I run the code, this prompts me to save the code naturally. I can save it of simple script, and it will automatically add the .m extension, short for MATLAB. It does the CLC and then it does the clear, and all of the outputs of our file here will be displayed on our command window. It is a bit equivalent to Python or any other programming language. It's very similar. Now, what you will notice is here, we have a is equal to 0, which is okay. Then we have 2 times 0, so we displayed it 2 times. Why is that? Now, you will see that in MATLAB, whenever you do something is equal to something, for example, a is equal to 0, or b is equal to hello world, for example. Let me do it here. B is equal to hello world. Let's say hello matrix. Change a bit the convention. Okay, so hello matrix. If I do here this A and then this B, okay, I run this code, you'll see that we printed A, we printed B twice. This is because in MATLAB, whenever you have something is equal to something, it will automatically display what this variable is equal to. As you can see here, we have a little bit of a highlight. They said add a semicolon after the statement to hide the output in a script. In a way, if you have a is equal to 0 and then you add a semicolon, so this is a semicolon, it will hide the output of a here, and it will be only displayed here and here, here and here. If I run the code, you'll see that now we have a 0 and hello matrix. Now, this is a very basic introduction on how you can write your scripts. Another thing I wanted to show you is how you can make comments in MATLAB. For example, let's say that I have here a is equal to 0, okay? I say b is equal to 3, for example, and I say c is equal to, let's say, -1. To add comments within MATLAB, you simply use the percentage. So percentage here, I can say define a, here as well, defining b, and then here, defining c. So this is how you can make a comment within MATLAB. Of course, you can do a comment within multiple lines. For example, here I can say a, you'll see that it will automatically add like a block of comments, and I can reduce it, for example. Okay. Here, let's say this is a comment over multiple lines, and I can continue working on my code. For example, here d is equal to, for example, 1, 2, 3. I can reduce this comment if I don't want it to take too much space. Now, there is something else you can do with comments, is to actually structure your code. If I do here double comments, this will create a section. So let me call this section 1. Okay. Let me actually hide this one. Okay. And let me call this section 2. You'll see that now, if we select this block of code right here, it will be highlighted with blue. If I select here and click on this part of code, it will be highlighted now on blue. So anyway, MATLAB has a feature that allows you to fragment your code to different sections. Since you fragmented your code to different sections, you can either choose to run this block of code right here or this block of code right here. This is done with this thing. So run section. If I run this section, you'll see that we define A, B, and C, but we did not define D, since we did not execute this section right here. If I do now run this section, you'll see that we successfully executed this one right here. Now if I add a CLC and a clear, okay, on top this one, okay, I rerun this section. You see that now we have just A, B, and C. If I do the same thing here, and run just this section, you'll see that we have just D. Now if I want to run the whole code, I simply hit on this run button. You can see here run, it runs everything. I need a little break. Always feels refreshing. It is actually AT, so it's not refreshing, but anyway. So now I want to show you something called creating matrices. Since MATLAB is short for Matrix Laboratory, all the heart is creating matrices. Now, again, the good practice is starting with a CLC and then a clear. Okay. Now, to create a matrix within MATLAB, which is something we'll often do, and actually everything in MATLAB is treated as a matrix, even for example a string, a integer, all of them are treated as matrices. Now, to create a matrix within MATLAB, you simply specify brackets as a normal matrix between brackets. And then if you want to have a 1D matrix, i.e. a vector, you specify the elements, so 1, and then comma 2, comma 3, comma 4. If I go ahead and add a semicolon, remember to not display the output, and do a disp A, okay, I want to run the code here by hitting this button. You see that this is our A matrix. Okay. Now notice that since we executed our code, we have saved A in our workspace, so we can go ahead and actually use it directly in our command window. This is good, for example, if you have a script. You have a script here with a bunch of variables. You run it and you want to debug it in the command window. You can do it, for example, here we have A, and I want to do, for example, A times 2, okay? And you will see that this will get 2, 4, 6, 8, and so on and so forth. Or if I do, for example, A minus A, we get 0, 0, 0, etc. Now, this is how to create a 1D. So this is a 1D, let's say vector, or just a vector. To create a matrix, here, let me call it A is equal to, it is exactly the same thing. This can represent the first row of our matrix. Let me actually copy down all this. Now, to create the second row of our matrix, you gotta specify within that matrix a column, a semicolon. And then you can continue defining the second row. So 5, 6, 7, 8. And then again, 9, 10, 11, 12, and so on. Now, if I go ahead and display A, so this one will overwrite this one, okay? I run this. See that here is our A matrix. Now, if you want to have it a little bit more structured, of course, you can come here and hit enter to shift a line, okay? And then here as well, so that you can, in a way, see more clearly what your matrix is about, what it is equal to. And see here, we get the exact same result. Now, there are so much operations you can do on matrix, and I suggest you, if you have a question, you simply have to go to the MATLAB documentation, so hit MATLAB documentation. Okay, so let me do this. It is in German for some reason. Wait a minute. Alright, so don't ask me why it is in German, okay, but let's say I set here matrix, and here it will give you all of the operations you can perform on matrix. We'll speak about this one. it is very a wide, since its solely purpose is to deal with matrices. You see here we have all the operations, a bunch of informations. It is basically the MathWorks documentation under array versus matrices. Okay. Now, since we have this matrix right here, so let me do this again. Okay. And let me call this B, for instance. Now, when you have a matrix A or B, matrix multiplication, for example, here, I can go ahead and do B plus 5. It adds 5 to all of the elements here, so we have 1 plus 5, and so on and so forth. If I do 5 times B, it will multiply all the elements with 5, okay? I can also go ahead and do, I think, B divided by 5, yes, this gives the same result. It divides all of the elements by 5. You get the idea, right? Now, if I do B squared, I want to square all the elements within B. If I do this, you will see we will get an error. It says incorrect dimensions for raising a matrix to a power. Because here, MATLAB thinks that we want to do B times B. So this is B squared in a way. Now you will know from linear algebra that you cannot square a matrix if it is not squared, if it doesn't have the same number of rows than columns. Okay, so this will not be possible. What we want to achieve is do the squared of all the elements. So you gotta do B and then dot, and you specify the squared. So whenever you do dot and then the operation, this tells MATLAB that, okay, I want to have a element-wise operation. And then let's say that now you create a C matrix that is a 3 by 3 matrix. You do a rand. You'll see that C now is a random 3 by 3 matrix using the rand function. I can go ahead and do ENV of C to get the inverse. Okay, I can get the squared matrix here, so it's this one. So you can play around with all of this and discover it by yourself. But know that in MATLAB, whenever you want to do something, just Google it. Just Google the function or ask ChatGPT how you can find it. But now you see that globally, this is how we define a matrix. Okay, this is how we perform element-wise operations, doing the, for example, C and then dot squared. Okay, if you want to have the eigenvalue of C, just do egg and C, and so on and so forth. Now, this was all about matrices. We can also go ahead and deal with if statements. Now, if statements, it is very straightforward. You do if, okay? For example, we have if x is greater than 0. You hit enter. You write your normal if statement. For example, here, this x is greater than 0. And then you can see here we have a problem. It says an end might be missing. You have to know that in MATLAB, a block of code is known when we have, for example, the keyword, for example, if, and MATLAB knows that this block of if statement ended with the end syntax here. If I go ahead and run this section right here, we will get an error since I didn't define x. Let's say that x is equal to 0. I run this section. Okay, so we see we get nothing since we don't have an else statement. So let me actually add an else statement. I do an else. Okay, say this x is lower than 0. There we go. If I go ahead and run this, we can see here that x is lower than 0. So this is basically how the if statements work. If I want to stack up conditions here, and I say y is equal to 0 as well, I say x greater than 0 and y greater than 0. So in MATLAB, this is the AND gate. Okay, so if I run this, you'll see that, let me actually add here. So I'm not verifying the logic behind this. I just want to show you this. You see here that x and y is lower than 0. If you want to check x or y is equal to 0, you simply do this symbol right here. You see we'll print this one. So let me actually do a CLC clear. Okay, let me run this code. You'll see that x, since we took either x or y is greater than 0, and we have here y is greater than 0, so we will display this one. And the else if is simply specified by doing an else if here. Okay, so let me do else if. I just throw around just a bunch of conditions, for example, here, and then I do and. You see that it works. So basically, this symbol stands for the AND, and then this symbol stands for the OR gate. Now, when we dealt about Now, after dealing with the if statements, we can also see the loop statements. So the loop statements is basically the same thing where you have a for loop. Okay, so for I is equal to, and then let me jump this to an end. Okay. Here, the I, by doing a CLC here once again, this will be here a vector. So a vector. Remember again, a vector we define it like so. So let me just copy down this. Okay. And let's say here we have a vector is equal to this. If I do for I is equal to vector here and then I do this I, or simply I, this will print I, okay? I run this, you'll see that we get 1, 2, 3, 4. I can also go ahead and do -1, 0, 0.5. You see that it also works. This is equivalent in a way that I, here, will take sequentially all the values within this array. So first of all, it will be -1, and then 0, and then 0.5, 1, 2, 3, 4, and so on and so forth. Now, how do I get actually access to these elements within this vector right here? So this element right here, and if I run this, I get access to the vector, okay? To get access to the first element, I gotta specify vector parentheses 1. Because you have to know in MATLAB, actually, it starts counting from 1. It is amongst the very few programming language that starts counting from 1 and not from 0. So vector of 1 returns -1. Vector of 2, for example, it is 0, and so on and so forth. If I want to get the last element, this one, so it is 1, 2, 3, 4, 5, 6, 7. If I do vector of 7, I get 4, which represents the last element. Now, another way to do this is by specifically defining an n representing the length of the vector. So I do n is equal to length. This length function will return the length of a vector, okay? You can see here this is equal to 7. Now, if I do vector of n, you will see that we will return 4. Now, similarly, implementing this logic right here, instead of doing I is equal to vector, so instead of it being equal to these values, we want it to be equal to a vector going from 1, 2, 3, 4, 5, representing the indices of our vector right here. To achieve this, you do I is equal to 1, and then column, a length of vector. So basically in MATLAB, whenever you see here one column and then something, let me actually show it here. If I have 1 column 10, it will create a vector from 1 to 10. So the start is 1, the end is 10. And it assumes, since we didn't specifically specify it, that the step between the elements is 1. If, however, I do 1 column 2 column 10, you'll see that we get 1, and 3, 5, 7, and 9. So we basically start from 1, we end at 10, but between each 2 consecutive elements we have 2. So 1, the first element is 1, the second element is 1 plus 2, which is 3, the third element is 3 plus 2, which is 5, this one, okay, and so on and so forth. So this means here, if I do I is equal to 1 column length of vector, now let me rerun this block of code right here, you'll see that we get I goes from 1, 2, 3, 4, basically representing the indices of this vector right here. If I go ahead now and say vector I, okay, I run this code, you see that now we output the actual values of our vector. Now, similarly, for the for loop, you have the while loop, where you do simply while, you specify your condition right here, and then you end it with the end keyword, and you simply specify here your block of while loop. That being said, I hope you were able to grasp a little bit of all the concepts in MATLAB in this very quick crash course, and maybe give you a head start to work on your own on your project. Anyway, thank you so much for watching. I hope you enjoyed watching this video. If you have any suggestion, or if you want to have a more detailed course about MATLAB, please let me know in the comments. But I tried to condense it to give you the essential in like 30 minutes or 25 minutes. So I hope everything was clear to you. If it wasn't, let me know in the comments. Anyway, thank you so much for watching, and I see you in the next video. This has been Yunus, and peace. By the way, if you enjoyed this video, please feel free to follow me on either of my social. I have a LinkedIn, a YouTube, and a GitHub channel, so feel free to follow me in either of these socials. If you feel like generous and want to support the channel, check the description. I have also made a PayPal account for some reason, if you feel generous, of course. That being said, I hope you enjoyed the video. Thank you so much for watching, and I see you in the next one.